Next, we have Dr. Stefan Heunis, who is a research data and software engineer in Jülich, where he works as part of the Psychoinformatics Lab on software solutions for decentralized research data management. And today he's going to be talking to us on DataLad. So thank you so much.
Hi, thank you for the intro. Can you see my screen and see me and hear me?
That's good, yes.
Cool. I'm posting my slides in the chat if anyone wants to follow along remotely. Cool, great to be here, thank you. I am going to speak about DataLad, and I want to refer back to the talk of Patricia about the situation where people have varying data structures at different sites. And this what could be a common problem of making these things come together in a specified format. So you have bits, which is great for that. But I wanted to note that a tool that could be great for the steps preceding that is something like DataLad, because it helps you to track all the changes that you make to your data sets as they evolve over time. And I thought that was a nice slide presented by Patricia that also fits with what DataLad can do. So let's see what DataLad can do. So a very kind of quick overview of what DataLad is. It's a free and open source tool. It's built in Python, but it has a command line API and Python API and a graphical user interface, which is still early in the development phase. But it's used for decentralized research data management. It's not specific to research. It could be any type of data. You could manage your list of personal art projects with it, or MP3s, or whatever. Sorry. And the main function of DataLad is that it allows exhaustive tracking of any type of digital or objects over time. And not only the tracking of those objects as they change. So it's not that it can only track your version of your article as you first drafted, then goes on to version 2, version 3, but also things like data and data sets and how they change over time, specifically also in reaction to some sort of computational process that you apply to it. So that's the general kind of gist of what DataLad does, but I'll explain it a bit more in terms of what the session is also about, data sharing. So I guess many people, if you've worked in the area of data sharing, you would be familiar with these FAIR principles of data sharing, which is findable, accessible, interoperable, and reusable. And everything should be fair. There's a big focus on that nowadays, but what does it actually mean practically for us as researchers? Especially given that we have limited resources, right? The researchers are these days expected to do basically everything and be experts in everything. And they have all the knowledge necessary to describe data, for example, but do they have the time and resources to do that? And are they motivated to make their data fair as kind of aspirational goal, or they just need to finish what they're busy with? Sorry, I have a bad cough. So with DataLad, we try and ask the question, why don't we build a tool that can help us enable practical collaboration, even if it's just with myself or my future self? And why not make fair data a kind of a side effect of that, or byproduct of just using a tool to enable efficient research? So as you do in academia, you always have an acronym for everything. So we said, let's go with VAMP instead of FAIR. And what we mean with that is version controlled, actionable metadata, modular data, and portable data sets. And I will explain a bit more what that means. But the point is to have a tool that one can use every day in your work as you collect data, as you change the data, as you apply processing or analysis to it, and as you generate results to track your changes to that. And I'll explain a bit more with the story. So let's say we have a research team. They want to make their data fair, but their challenge is big. Like, what do you actually do to make your data fair? What do you do with the data structure? Yes, you could use something like bids. Where do you actually put your data? Do you have on-premise storage options? Do you have a server at your university or institute? Do you use public repositories, online stuff in the cloud? How do you transport data between places and to people that need to access it? And how do you link different data sets? How do you link a specific data set with all the derivatives that came from it, or to the processing pipelines that actually were applied to it? And they've come across DataLad. They can install it. It's free. It's open source. You can install it on all major operating systems with a bunch of widely used package management solutions. And the first thing they come across is this thing called the DataLad dataset. And that's like the kind of modular unit of DataLad itself. And if you're familiar with things like version control in software, and with data management at this kind of technical level, you will see that DataLad is essentially a wrapper around existing and widely used tools. And these are called Git, which is for version control, and Git Annex, which is to manage large file storage and access. So DataLad uses existing open source and extremely widely used tools to cater just a bit more towards data management and evolution of data sets over time. So you can create a data set, and what this means is you just have a regular folder or directory on your system, and it has files and folders itself. It's got a tree that has some content, and now turning that into a DataLad dataset means it's now managed by DataLad. It doesn't change much about it or change anything about the data itself. It just now is actually a Git repository, and it knows about with Git and Git Annex, it knows about the location and the content of each of the files in this tree that you have on your computer or server or somewhere. And it knows about this because it gets the metadata from these files and stores it in this kind of modular unit called a DataLad dataset. So in essence, it becomes a let's say you have a big dataset like this big brain MR dataset, or you have a bits dataset somewhere, or whatever type of data. It could be lots of storage space that's required, but all of this data could be represented as a DataLad dataset in about a few kilobytes, because it essentially describes the full content of your dataset using metadata. What is enabled because you use it as a DataLad dataset is the core concept of tracking changes to your dataset. So and this is completely based on Git principles. So you can use the things called branch, add changes, commit changes, merge different branches into each other. It essentially means something that reflects reality, right? So you're gonna use version A of a bits dataset. You're gonna apply some analysis pipeline to it. It's gonna change to something else. It's gonna generate derivatives. Or you realize that the name of one of the files was incorrect. You need to change it. Or you want to apply a variation of your analysis pipeline and change the data set somewhat. Now, all of these changes, if you are using your own human mind, can become quite difficult to track. What did I do in that pipeline? What did I do with this data set or those derivatives? And using Git for version control of your data allows you to outsource all of that out of your mind and put it into a system that is established globally as a kind of a standard tool for tracking changes to digital objects. And then you can save these things as well. So with a DataLad save, you write a message that says, in this pipeline, I apply this and this and this. And then DataLad can show you what was the state of the data set before, what was the state after. It is also something that allows you to publish your data to various sources. So let's say we have a DataLad dataset from a BIDS dataset, or from just a bunch of MP3 files on my system. I want to be able to show other people that this data exists. I can now take the DataLad dataset, the modular metadata-based unit, and publish it to something like GitHub. And people can see, hey, there's the name, there's the tree, there's the folder structure. It looks like it's a real dataset. When they click on the actual files, they will see something like a symbolic link. And that is Git Annex doing its job of saying, this data is part of the dataset, but the actual file is stored elsewhere. And this is also the powerful aspect of DataLad, that in the sense that you can store your data in a specific place, which is also very useful for privacy, for example, or security reasons. So keep your personal data somewhere that is important to keep secure on a server somewhere, and with very specific access restrictions. But publish, for example, the metadata in a public place that people can find it, and they can see the structure and figure out how to interoperate with it. But when it comes to access, they will first need credentials to the actual storage server to get that. On the other hand, when data is published somewhere, data can also be consumed somewhere. So, and this is also quite a nice and powerful aspect of DataLad, in that I can clone a DataLad dataset, meaning that I can get a copy of that modular dataset on my local system from something like GitHub. And it is just a small set of metadata that describes the full dataset. And so firstly, I don't have to copy terabytes of data or hundreds of gigabytes of data to just be able to see what it looks like. I can see it immediately with a matter of kilobytes, and I can decide when and which file I need for a specific purpose, and then get that and only that when I need it. And that is done with the DataLad get, which then takes as an argument a specific file or a specific subdirectory and all its contents. And the cool thing then is that if the data is public somewhere, it just gets the data from that place. Or if the data is restricted somewhere, it will know that it has to ask for credentials first. And if I don't have credentials, then I cannot get access to the data. So again, I can clone it. I can access the data set structure. I can find it. I can figure out how to interoperate with it. When it comes to access, I first need access. I first need to be able to have credentials to get that. And that's something one can typically then get by asking the controllers of the data for said access. And then I spoke about findability, accessibility, interoperability, and then the reusability is where the provenance tracking capabilities of DataLad are really, really useful. And what it does is that it allows you to stack data sets together and link them in a very specific and trackable way. So let's say I have a data set, and it uses a containerized pipeline. In this image, it's indicated by this picture of a container with the S of singularity on it. And I apply a very specific version of that code, of that containerized pipeline, to a very specific version of the data. And that application, that step of running the actual code on the data can be captured. So, and it captures the full provenance by a method called DataLad run. So basically, I just say DataLad run and then pass it the arguments for running this pipeline. And DataLad tracks all the changes to the resulting to the data files and generates a standardized provenance record, which can then be rerun at a later stage. But the importance is that it answers the question, which version of the data set was used, which version of the code was used, and in which environment was this applied, and which version of the output data did it generate. And I think that question becomes all the more important these days as we start applying multiple pipelines to multiple dataset versions over and over again to test different parameters, etc. And you don't have to keep track with of that in your head or in a place that you keep notes. You can keep track of that with DataLad. And DataLad can show you the complete history of what has been done to the data set at which point in time and how these results have changed. And you can go compare these outputs again. And also with the use of Git, you can go back to a specific version or a specific branch if what you did and you gives outputs that are incorrect, or that if you don't like it, you can also go back. So again, on the rerun and reproduce, the R of fair data, if we have the DataLad dataset and we have its linked to what we call a sub dataset at a specific version, which is the input data, and a sub dataset of a specific version, which is the code, and we have the provenance record of how those were applied to each other, we can rerun just that single record, and DataLad will fetch the code that it needs from wherever. It will fetch the data, the parts of the data that it needs from wherever, and it can generate an output. And you can compare this to the output that could be shared by the original person to see that they, on a bit level, they can reproduce. So I covered a lot of what DataLad can do. It integrates and extends with a lot of well-known and widely used infrastructure. So you can put DataLad datasets on GitHub, on the Open Science Foundation. You can put it on GitLab. You can put it on AWS. So anything that works with Git Annex remotes or Git Annex special remotes can be a hosting place for a DataLad dataset. If you're familiar with OpenNeuro, all OpenNeuro datasets are also DataLad datasets, and they can be fetched, and files can be fetched individually with DataLad. I want to quickly just run over a couple of use cases to bring it more into a practical world. The first being that something like Dataverse, which is quite widely used for data sharing, is that one can push a DataLad dataset also to Dataverse. And the nice thing about Dataverse itself is you can receive a citable digital object identifier. And again, in this case, you don't necessarily have to push the data there. You can push the DataLad dataset there, which is the metadata describing the actual data. And the data can remain where it is. And you don't have to kind of duplicate costs in terms of storage. Another nice aspect about DataLad and this part of splitting the data storage from the metadata describing the data set is the context of something like patient data, confidentiality, privacy related to GDPR in Europe, for example. And it allows you to keep the data in a place that is approved. Let's say it's GDPR approved by the data privacy officer of the specific institution, and all the names and etc. in the data set are anonymized, and the DataLad dataset can then be pushed elsewhere, hosted such that people can find it, they can understand the structure and know how to interoperate with it, and they can, for example, also clone the DataLad dataset without having access to the data. They can build a pipeline around the structure, and they can containerize that and they can add the container to the DataLad dataset and push it back to the confidential space. And this kind of allows this what is known as the code to data systems, where you build code elsewhere, you just push it to the place where it needs to be run because the data is there and the data needs to stay there. And then without breaching confidentiality or GDPR laws, you can access and analyze the data. Things like a reproducible paper that one of my colleagues made, the whole process of the data, capturing the data, structuring the data analysis, multiple steps of analysis, multiple variations of analysis, and then writing results automatically into a paper that is built with LaTeX. This whole process was tracked with DataLad, and in the end, one can reproduce the results just by one command saying DataLad rerun in a specific provenance record, and it can generate, it can fetch data where it needs, from where it is. It can run the same analyses that were reported in the paper and generate the actual output of the paper with figures that come from that. One thing that I'm working on, I see a video. I guess my time is.
Yes, if you don't mind wrapping up, that'd be great. Thank you.
Yeah, sure. I can end with this because I'm also very excited about this. The DataLad catalog extension. So it provides a nice way to present all this metadata in a catalog online. It looks like you're browsing actual data, but it's all based on metadata, and people can then quite easily clone these data sets and or request access to the actual data itself. And the very last point, we have a conference coming up next year in April. If anyone wants to join, there's a link of it, but it's essentially everything that I talk about now will be discussed and presented in much more detail and with much more enthusiasm next year, April. Thank you for your time.